Hi guys, so let's finish question 9 of January 2019, paper 2 CSEC Math. We did part A in the previous video, which is on circle theorem. So part B has to do with angles of depression. So we have a diagram. The person at the top of a lighthouse TB sees two ships S1 and S2 approaching the coast as illustrated in the diagram below. The angles of depression are 12 and 20 degrees respectively. The ships are 110 meters apart. So part 1, complete the diagram below by inserting the angles of depression and the distance between the ships. Okay, so the angles of depression are 12 and 20 degrees respectively. So angles of depression are measured from this horizontal line here, this dotted line. So the first angle, which is 12 degrees, would be the smaller angle. Let me write that over. Okay, so my stylus is just giving a bit of trouble. Okay, so that angle is 12 degrees. And the bigger angle, which would be this angle here, would be 20 degrees. So we have our angles of depression. So they said that the ships are 110 meters apart. So this is ship 1, S1, and ship 2, S2. So if the ships are 110 meters apart, it means that this distance is 110 meters. So that's one mark to put in both angles of depression and the distance between the ships. So part 2, we have to determine to the nearest meter the distance TS2 between the top of the lighthouse and ship 2. So this distance, which is the hypotenuse of this right angle triangle here, TS2 is the distance we need to find. However, the only distance we have is this angle S1, S2 in this triangle. Let's see if we can develop a relationship between the angles of depression and the angles of elevation from each ship to the top of the lighthouse. So by alternate angles, if this angle is 12, then it means this angle here is also 12, since they are alternate angles. And since this angle is 20, that means this angle here is also 20 degrees, right? Since they're alternate angles. Now, since we have that information, let's just label this side of our triangle X. All right, TS2, that's the distance we need to find. So I'm looking at this triangle TS1, S2. All right, this kind of scaling triangle here. So we have one angle, we have one side, and we need to find the other side. So let's find this angle here, which is the other angle on this straight line. So since this is 180, 180 take away 20 will be 160. So this 160 degrees is the angle opposite the side that we want to find. So it means that I could use the sine rule here, because in order to use the sine rule, if I have an unknown side, I must have the angle that is opposite to that unknown side. Now, if this side is 110, it means I need to find the angle opposite to that side, which would be this angle up here. Now, if this is 12 and this is 160, then I could add 160 and 12 and subtract it from 180. So 160 plus 12 is 172. So 180 minus 172 means that this angle here is 8 degrees. And of course, that also makes sense because the difference between the two angles of depression, 20 take away 12, is also 8. So let's use the sine rule. So 110 degrees sorry, 110 meters divided by sine of 8 degrees is equal to x divided by sine of 160 degrees. degrees. Okay, so let's cross multiply. So x multiplied by sine of 8 degrees is equal to 110 times sine of 160 degrees. So x will be 110 times sine 160 divided by sine of 8 degrees. Now we could input this directly into a calculator, right? Because this is just worth 3 marks. So 110 sine 160, and then divide that by sine of 8 degrees, and we will get x to be 270 meters. All right, to the nearest whole number. Okay. Let's go on to part B, the height of the lighthouse TB for 2 marks. So TB, the height of the lighthouse, so let's label this distance y. So now that I have the hypotenuse of my right angle triangle, which is TS2, remember x we found was 270 meters, I can use the big triangle TBS2 in order to find the height of the lighthouse TB, which is the unknown side y. Because this angle is 12, the hypotenuse is 270, so therefore y would be the opposite. Alright, and x is our hypotenuse, so therefore we need to use sine. So sine of 12 degrees is equal to opposite, which is y, over the hypotenuse, which is 270. So y would be equal to 270 times sine of 12 degrees. And again, we could just input that directly into our calculator. 270 times sine of 12 degrees will give 56 meters to the nearest whole number. Okay, so that's 2 marks.